This time we're doing dilations with different centers. So what we're looking at to do is we're going to have to move the center to the origin, dilate the object, and move it back. So if we look at the instructions in number 1, it says to dilate by a scale factor of 1/2, and the center of this dilation is right here at 0, -3. What we want to do is move that center up to the origin. So what we're going to do is we're going to move it up 1, 2, 3 units. So we're going up 3 units. To put it back, we're going to have to go opposite of that. So at the very end when we put it back, we're going to have to go down 3. So now if we take every single point here and we go up 1, 2, 3, and we're going to take the K and go up 1, 2, 3, then we're going to go ahead and find what our J is currently. J is here at -3, -2, and K is here at 3, 2. Now we're ready to dilate this by its scale factor now that we've moved it up. So when we dilate, we're going to dilate by 1/2. So when we get J prime, 1/2 of this -3 is -1.5, and 1/2 of -2 is -1. Then we do K prime. 1/2 of 3 is 1.5. 1/2 of 2 is 1. So now let's go ahead and plot those points. So we're going to do -1.5, -1. So that's currently here. We don't need this anymore. We don't need this. And then we have 1.5, 1. And now what we need to do is put it back. To put it back, we're going to move each of these down 3 units. Down 1, 2, 3 is where this one's going to be. Down 1, 2, 3 is where this one's going to be. So this is now my new J prime. This is my new K prime, and it's right here, this segment. Now what we're going to do in number 2 is number 2 says we've got a reduction, and we're trying to find the center and the scale factor. When you're doing this, you're going to want to take like a piece of paper or a ruler. You want something that has a straight edge, and you want to be pretty precise on this because it's easier to see the center. So I'm even going to switch pens here. But to find the center, what you want to do is you want to connect your dots using a straight line. And what we're talking about connecting where the primes would be. So for example, if this is A here and we've got A here, let's look at what this is going to be, which one's going to be the original. If it's a reduction, it's getting smaller, so that means that this has to get smaller. So there's my A prime. And like if I want to call this B, then this would be my B prime. So you're going to connect the dots, the primes that go together. And again, it's very important that you use a straight edge of some type just because you want to make sure you're accurate on this. So there we're connecting those two together. And then this one here, we're going to connect together. Give me just a second to make sure I get a strong line here. There we go. And that's pretty close. You can see why it's really important to use that straight edge because it looks like it's intersecting right here. And so we would say that the center for this particular dilation is here at 1, 3. Now we just need to figure out what the scale factor is going to be. Now when you do the scale factor here, you really kind of want to know how far the original is from this point, which we call the center. And so when we do that, just double checking my work here. Yeah. So when we do that, we want to take this 1, 2, 3, 4, 5, 6 to the center. So it's 6 to the center for the B. And then if we count the other B, here we've got 1, 2, 3, 4 to the center for that one. Now it's a reduction. And so your idea here is that what could I have multiplied this by? The way I always think of it is it's either got to be 6/4, it's got to be 4/6 as the scale factor because it's either 6 units to the 4 or 4 units to the 6. Now here's how I can pick which one it is. Remember, we're getting smaller. So which one of these, if I used it as a scale factor, would make it smaller? And the answer is the fraction here. So it can't be this one. 4/6 would reduce to be 2/3, which would be the scale factor. So my final answer here is center is at 1/3, and then the scale factor is going to be 2/3.